Have you ever looked up at the night sky and wondered if we are alone in the universe? This question has sparked the imaginations and fueled the curiosity of humankind for as long as we've had the capability to gaze upwards and ponder our existence. The enchanting tales of little green men and spaceships are more than just bedtime stories. They represent our yearning to understand our place in the cosmos, to break the boundaries of our loneliness, and to reach out to potential cosmic neighbors. This fascination gave birth to an ambitious endeavor called the Search for Extraterrestrial Intelligence, or SETI. The origins of SETI lie in the mid-20th century, when advancements in technology allowed us to start actively seeking out signals from beyond our celestial backyard. The simple premise of SETI is this: if there are technologically advanced civilizations out there, they might be broadcasting their presence, and we just need to tune in. A key piece of this cosmic puzzle is the Drake equation, formulated by astronomer Frank Drake in the early 1960s. It's not so much a strict equation as it is a tool for stimulating intellectual discussion. It considers factors like the rate of star formation, the fraction of those stars with planetary systems, and the likelihood of life developing to estimate the number of civilizations in our galaxy with which we might come into contact. But the Drake equation also underscores the enormity of our task. It's a constant reminder of the vastness of space and the challenges we face in our search. Each term in the equation is filled with uncertainties, and small changes can drastically alter the outcome. Yet despite the odds, our quest continues. The search for extraterrestrial life has been a journey filled with hopes, disappointments, and enduring mysteries. As we continue to scan the cosmos, we remain hopeful that one day we might finally answer that age-old question: are we alone? The quest for answers began in earnest in the mid-20th century. As our own technological abilities took a giant leap forward, so too did our curiosity about the cosmos and the potential for life beyond our own little blue planet. One of the first serious attempts to seek out our celestial neighbors was Project Ozma, launched in 1960. Named after a character from The Wizard of Oz, the project was a pioneering effort in the search for extraterrestrial intelligence. It operated under the premise that if there were intelligent life forms out there, they might be using radio signals to communicate, just like us. Despite the high hopes, Project Ozma didn't detect any clear signs of extraterrestrial communications, but it did open the floodgates for more ambitious projects. One such endeavor led to the discovery of the WOW signal in 1977. This strong, narrowband radio signal detected by the Big Ear radio telescope lasted for 72 seconds and has never been detected again. Its origin remains a mystery, and it continues to fuel speculation and excitement about the possibility of intelligent life in the cosmos. But we did not just listen, we also reached out. The Pioneer plaques, attached to the Pioneer 10 and 11 spacecrafts, were our first cosmic messages in a bottle. These plaques, bearing images of a man and a woman along with other symbols, were designed to communicate the existence of human life to any extraterrestrial beings that might encounter them. Then came the Voyager Golden Records, launched aboard the Voyager 1 and 2 spacecrafts in 1977. These gold-plated copper discs carry sounds and images selected to portray the diversity of life and culture on Earth, a kind of time capsule for the cosmos. While these early attempts didn't provide definitive evidence of extraterrestrial life, they laid the groundwork for future exploration. These endeavors, filled with both hope and uncertainty, continue to inspire us as we reach out into the vast expanse of the universe, ever hopeful of making that monumental connection. As technology advanced, so did our methods of searching for life beyond Earth. From the early days of scanning the cosmos for radio signals, we've broadened our horizons. The search for extraterrestrial life has evolved, and now we're not just listening, we're looking. In the late 20th and early 21st centuries, our focus shifted towards the hunt for exoplanets, planets that orbit stars outside our solar system. With this shift came the development of advanced spacecrafts, like NASA's Kepler mission. Launched in March of 2009, Kepler's primary goal was to discover Earth-sized planets orbiting other stars. And it didn't disappoint. Kepler discovered a staggering amount of exoplanets, many of which are located in what we call the Goldilocks zone. Not too hot, not too cold, but just right. This zone is a habitable region around a star where the conditions could be just right for life as we know it, based on the availability of liquid water. After all, water is the lifeblood of our planet, the key ingredient that supports life here on Earth. So, it stands to reason that if we're going to find life elsewhere in the universe, it might be on a planet where water can exist in a liquid state. But the Goldilocks zone is just one piece of the puzzle. An exoplanet could be in the perfect zone and still not support life if other conditions aren't met. It needs to have the right kind of atmosphere, the right kind of chemical elements. It's a complex, intricate search, but one that's necessary. The Kepler mission has since ended, but its legacy lives on. It has given us a broader understanding of our place in the cosmos and has brought the possibility of finding extraterrestrial life within our reach. The discovery of these exoplanets has brought us one step closer to answering the question of whether we are alone in the universe. The search for extraterrestrial life continues to this day with more sophisticated tools and approaches. We've come a long way since the early days of scanning the skies with radio telescopes, hoping to pick up a stray signal or two. Today, our search for alien life is both broader and more focused. And it's not just about looking for intelligent life. We're also on the hunt for the simplest forms of life, microbes. Take, for instance, the James Webb Space Telescope, the most powerful space telescope ever built. Set to launch soon, it will peer into the farthest reaches of the universe, looking back in time to the very early universe. But it will also help us in our search for extraterrestrial life. It's equipped with instruments capable of detecting the chemical signatures of life known as biosignatures on distant exoplanets. Closer to home, we're exploring our own solar system for signs of life. Mars, with its similarities to Earth, has always been a prime candidate. The Mars rovers, like Perseverance, are looking for signs of past or present life, from fossilized bacteria to signs of current microbial life. Beyond Mars, the icy moons of Jupiter and Saturn hold promise. Both Europa and Enceladus harbor vast oceans beneath their icy surfaces, kept warm by tidal heating. Could these oceans be teeming with alien life? Future missions aim to find out. Then there's the Breakthrough Listen project, the largest ever scientific research program aimed at finding evidence of civilizations beyond Earth. Using the most advanced observing equipment, it's scanning the million closest stars to Earth, looking for signs of advanced life. These are just a few of the exciting endeavors underway. As technology advances and our understanding of life's requirements expands, who knows what we might discover? Microbial life on Mars, complex organisms in the oceans of Europa, or perhaps a signal from an advanced civilization light years away. As we continue to explore, the possibility of finding life beyond Earth becomes ever more tantalizing. The journey to find extraterrestrial life is a testament to human curiosity and ingenuity. In this vast cosmic playground, we've embarked on an ambitious quest to answer one of the most profound questions. Are we alone? We started off with the early attempts to connect, harnessing the power of radio signals, hoping to intercept a cosmic conversation, a testament to our unwavering optimism and scientific creativity. Our search then broadened, moving from the invisible waves of the electromagnetic spectrum to the distant celestial bodies. We began exploring exoplanets, those fascinating worlds orbiting stars beyond our solar system. With each new discovery, our understanding deepened, and the possibility of finding extraterrestrial life seemed ever more plausible. In the current era, our endeavors have taken a quantum leap. From sophisticated space telescopes to ambitious missions targeting the moons of Jupiter and Saturn, we are leaving no stone unturned in our pursuit. The future prospects are even more exciting, with the promise of advanced technologies that might finally help us detect signs of life beyond Earth. But this quest isn't just about finding aliens, it's about understanding our place in the universe. It's about realizing that despite our differences, we, as a species, share the same origins, the same cosmic dust. The discovery of extraterrestrial life could redefine our perception of life itself. It could unite us, reminding us that we're all passengers on the same spaceship, our beautiful blue planet. However, the road to discovery is often paved with uncertainties. It requires patience, perseverance, and a dash of daring. But isn't that what exploration is all about? Venturing into the unknown, fueled by curiosity and driven by the desire to unravel the mysteries of the cosmos. As we continue to gaze at the stars, the question remains, are we alone? Only time and our relentless pursuit of knowledge will tell.